All right. So yes?
Are we going to get like a final review for like the test?
I was going to, but then I decided there's no point.
No.
This whole week basically is review week. Yeah. So I do have a handout today about factoring. We'll go over it. And then tomorrow, if I bring anything with me, I'll bring an answer key for it too. So you have it. I make these promises. We'll see. This week is insane. So a real quick review of factoring. If you're really nice to yourself, you have that factoring sheet somewhere easily accessible. If you're mean to yourself, then shit, man, math is already hard enough. Don't be mean to yourself. What's the first thing you always try when you're factoring? Yeah, you always try GCF first. Because either that's the only thing I can do, or it makes it possible to do. So if you see this here, and what can you do with this? I'll tell you what you can do with that, Jeff. No. Take out what? Yeah, so the numbers, what can come out of the numbers? 2. And then do the letters one at a time. How many X's can you take out the most? 2. He can give 3, but he can only give 2. And how many Y's? He can only give 1. And see, remember how I offset that a little bit so I can put the answer there, so I don't miss anybody? It's kind of the most heinous little mistake to make is to put this there and then forget this poor dude. Well, what's left over for this dude? 2. That's it. You took all of his other stuff. Poor dude. Right, we're like the semi-nice tax people. We don't take more than you got. We just take everything you got. Which is actually nicer than the tax people sometimes. 10 divided by 2. 5. I had 3 X's, now I have 1. And 3 Y's. I like it. And I know I'm done because no numbers come out and there's no variables here, so there can't be any variables like to both. Common to both. Okay. Does that sound familiar? Alright. And the next level of this would be a problem like this here. Alright, Jeff, let's see if we can do it. Oh, don't. Why do you make this so weird? Alright, Jeff, you'll be fine. Oh, yeah, this would be neat. So first off, you see anything that comes out of all 4 terms? No. And there are 4 terms. So the number of terms tells you what to do. Grouping. You got to love them. I mean, math problems normally are just like, here I am, figure me out. And this one's like, all right, let me tell you what to do. And that's kind of nice. So you group. What comes out of these 2? Yeah, 4. And 2 A's. And I did this on purpose, sort of. Well, it sort of worked out that way. Then I liked it and I kept going. There's a big mistake people make. Somebody will do this. They'll say, okay, 8 divided by 4 is 2. I got 1 A left and a B. And that's gone. Yay. I made a mistake right there. I made a mistake. What mistake did I make? Did I make a mistake or am I just bullshit? How do I check my work so far? I multiply and see if I get this back. Will I get this back? No. What am I going to be missing? That dude. So there's 2 ways to look at this. I need to hold his place. That's a placeholder. Or, what's 4A squared divided by 4A squared? Freaking 1. So, yeah, don't think it's gone. You're dividing it out. Because what do I do when I distribute? Multiply. So when I take it back out, I divide it out. That divided by itself is 1. what comes out of this whole thing, realizing I need this term to end up positive, what do I take out? A negative 5. So that's going to change both of these signs so it'll match up with this. Or that I want this guy and this guy to be the same, or else I can't do shit. It means I've done something wrong, or it's an evil prime problem. Be really careful. I normally put, like, at most 2 primes, normally 1 prime. A lot of you guys on that quiz or the test, you just put prime, like every other one was prime. No. If you see that, you're wrong. Be careful. So, of course, what's left here? 2AB. Minus 1, thankfully that's the same. So I can do the last step. And the last step is the same as this. What is this guy and this guy, what do they both have?
2AB minus 1.
2AB minus 1. I like it. So 2AB minus 1 comes out, and then I'm left with 4A squared.
Minus 5.
Minus 5. Sure. Right, and then you had the classic problem, something like, something nice like this here. Let's make it a little bit more interesting. Why not, John? So what is it that you have to find here? Because I can start this off. I already know what it's going to look like. X squared is going to be x and x. That's nice. That's easy. Now the whole thing is what numbers have to go in here to make the other stuff work. So what do they have to do? What do these two numbers have to do?
Multiply to equal 42.
Negative 42. You multiply to be negative 42. And then they have to add to be negative 11. Now some of you guys like to write it some weird shit way, whatever. If that somehow magically helps you, just putting a big X in there, I'm not going to knock it. Shit. Put the little magnetic thing on your wrist and you feel better. Guess what? Whatever. That's great. Whatever makes it work. I personally have no idea why that's any different than what I do. It's the same thing. You got to think the same thing. But I'll let it go. I'll let it go. If you like this thing, do it. I'll let it go. You're thinking the same thing. So I would rather start with, well, it depends. I mean, you guys can start making a bunch of 42 factors, right? Let me show you something kind of cool. What's the easiest way to do 42? It's 6 and 7 normally is what we think of. They ain't never going to equal negative 11, right? No. But, watch this. Isn't 6 2 times 3? So another factor of 42 would be 14 and 3. I can remix the factors together. What's cool about 14 and 3? They'll make negative 11 as long as 14 is negative. Okay, yes. Do you guys see that? I haven't really shown you that method. I think I showed a few people individually that method. But to break it all the way down to its DNA and then recombine the DNA, you become a math scientist. Excuse me for that. Sounds like some dumb Saturday morning math scientist. So then I've got... Now I'm done. Find it 14 plus 3. That kicks ass, right? That was the whole point, was to figure out what those numbers were to finish it out. That's kind of funny. And of course, to make this worse, I put a number here, right? So let me see. I'm gonna create one that works. Let me see if you guys. I'll let you guys just kind of watch me do stuff and see if you guys can pick up on how it works. Ooh, that would be gross. Well, it's like what we just did. No, I don't want to do that. Yeah. Oh, shit. So what do we have to do here?
What's it done? 14 and 6.
Yeah, when there's a number out front that's not 1, you got to take it into account. Just got to get involved in the mix. It's really what we did here. 1 times negative 42 is negative 42. So we actually always do it. 6 times 14? Bless you. 84. So you need two numbers that multiply to 84 and add to be 19. Notice everything's positive. Right? So my numbers are going to be positive, right? So it's easier to start with what adds to be 19. That's a much easier question than what multiplies to be 84. Who cares which one of these you make work first? Just check the other one. If it doesn't work, try something else. So what two numbers add to be 19? Yes. Oh, sorry. That's the answer. Well, like if I did 14 and 5, 14 times 5 is 70, right? So then I can try, we'll try 12 and 7, and that multiplies to be 84. I mean, that's I kind of knew what the answer was, but you just start off, and if I went the other way, if I went to 16 and 3, 16 times 3 is 48. I went lower than 70. Oh shit, I got to go the other way. I don't know if you guys see, the more you're able to just play with numbers, the easier that kind of thing is. So 12 and 7. Now what do I do with those two numbers? Yeah, so I'm going to break this guy up. I'm going to leave the 6x squared alone. I'm going to leave the 14 alone. I'm just going to break 19 up into 16x and 3x. Yeah, there's 16 and 3. 12x. I even circled it for myself, and I still couldn't do it. 12x and 7x. And now it's the same as this, right? Now I made 4 terms. So the whole point of this method is to take the 3 terms and make it become 4 terms. Because 4 terms is easy. I have no qualms saying that. If you're like, no, it's easy. It's got to be easy. This is easy. This, easy. So that, easy. What comes out? 6x. 7. These are the same, thank God. I can take that out and I'm left with 6x plus 7. Bam! Bam! Alright, and to round this out.
Question.
Yes, ma'am.
If this is one of the component tests, but like something like 64 and cubed minus 27.
Oh yeah. So remember, that one was a cubes. We went over it, but I told you I wouldn't put one on the test, and I did because I'm a mean person. But I made it extra credit, so I shouldn't have taken any points off if you tried it. You with me?
So
Yeah.
even if I got it wrong, do I still?
You could, but you don't have to correct it. It's extra credit. Yeah, I told you I wouldn't put one on there, and then I turned around and put one on there, and you're all like, "Yeah, teachers." I just forgot. It's just a normal thing to put on a factoring test, and it's really deep habit. So I'm not even going to talk again about little dude, big dude. I've already shown you that once. You're not responsible for it. If it shows up on the final, it'll be in the bonus section. The only 2-term thing we got to worry about is this kind of thing. And it's really the same as that. I need 2 numbers that multiply to be negative 49 and add to be 0, because the middle term is missing, right? 0x in the middle. It's the same thing, but then I can kind of make a shortcut and go, well, the only way that can work is if they're the same number, different sides. So who do I? Yeah, negative 7 positive. Cut x squared in half, cut 49 in half, minus plus. So then if I had something like this, 100z to the 10th minus. What do you got, Jeff? Put something in. All right, leave me alone. Let's do 81w to the 20th. Cut everything in half. That becomes, careful now, 10, good, not 50. Cut in half multiplicatively. 10, 10, z5, z5, minus plus, 9, 9, W10, W10. So difference of squares are always monster easy. You just have to identify the fact that it's a difference of squares. It's a difference. There's two terms. Everything can be cut in half. Yay. That's a thank God problem. Or a thank your favorite deity problem. So here, I want you guys to work on this.